Hi everyone, welcome back. I hope all of you are doing well. Today we're going to talk about version control and Git in specific. What is the problem we are trying to solve here? How many of you can relate to naming your projects like this? When you are working on like a Photoshop file or a document or anything, we used to name it like this. At least I did. Imagine having to do this with a software project having hundreds of thousands of lines of code and hundreds of thousands of different files. So whenever someone makes a change, they're gonna have to create a copy of it and say, okay, version 1, version 2, version 3, etc. Right? Obviously, that's not going to be practical, and there is no reason to do that. There are much better way to do that. That's where the version control softwares come into picture. So version control means a software that is used to help us version our files. It's as simple as that. So there are a bunch of tools out there that helps us with version control, Git, SVN, etc. But here we will be focusing on Git because this is the best tool out there for the job, and that is the most widely used one right now. Okay, so let's go ahead and install Git. If you are on Windows, you can either install the Git bash, which comes with its own terminal window, and you can run Git commands there, or you can simply use Git in the WSL as I am doing here. So if you have the WSL installed, you can install Git using sudo apt-get install git. Now I have already installed Git, so I'm not going to do that. Let's say we have an app called my app. So I have created a directory called my app here, and I'm going to cd into that directory. So this is a fresh project. We haven't done anything. So the first Git command that we are going to use is called the init command. Git space init, which means to initialize. So when we do git init, you can see that it says initialized empty git repository in this location. So in Git, a repository means a place where all your changes are tracked and stored. So in this case, this is a local repository. So there are two types of repositories in Git. One is local repository and the other one is remote repository. So local repository means the whole thing is stored locally in our computer's hard drive or SSD. Whereas a remote repository means it's stored in a remote server or a remote computer. If we are the only one working on the project, we can get away with having a local repository. But if we have multiple people working on the same project, we definitely need a remote repository too. We just initialized an empty repository here. If you do ls, you can see there is nothing there. But if I do ls-la to show hidden files and directories, you can see that there is a directory called .git. So this is the directory that stores all the information about your Git repository. Before we continue, I would like to take a moment and give you a word of advice. There are a lot of tools with user interface that you can use to do all of these Git commands, but I would strongly advise you to stay away from them until you learn all the Git commands. Using the commands are the best way to learn. If you start using the tools with the user interface, then you're not gonna learn the commands, and that's not good. So stick with the commands, forget about the UI for now. Also, Git can be pretty complicated. It has a lot of features, and most of the time we won't be even using the 90% of the features. Even I don't know anything more than I need on a day-to-day basis. I usually have to Google myself to figure out something when I mess up something. So my advice is learn the basics, use it whenever you can, and then when you are stuck, you can simply Google. You don't have to sit and learn all the advanced stuff Git has to offer. Just get an idea of overall how Git works and the basic commands, and then figure out things as you go. That's pretty much it. Okay, so we just initialized our local repository. So the first command we used was git init to initialize the repository. And the next one that we will use is git status, which, as the name implies, shows the status of the repository. So if you do git status, you can see that it says on branch master, no commits yet, nothing to commit. So there are three things here. One is on branch master. Git has this concept of branches. By default, we are in the master branch. I will talk about branches in a moment. For now, Just know that by default, all the repositories are in the master branch. And it said no commits yet. So that means we haven't made any changes that we are committed to. I'll show you what a commit means in a second. Let's create our first file in our repository. Let's create a README document. Let me just give it a title. That should be it. Alright, so I just created a new file. You can see that the readme.md file has been created. So now if I do git status, again it's on the same master branch, no commits yet, but here it says untracked files readme.md, and it also gives you a hint, use git add then the file name to include in what will be committed. So far nothing is added to commit, but untracked files are present, which is this. So what this means is, by default when you create a file or make changes, the files are untracked, meaning the changes are not stored in Git. Mind you, the file does have the contents that we created, it's just that we haven't stored these changes in Git yet. So let's say I want to store this change in Git. So I have to add this file to the staging area. Before you commit a change, you have to add that file to the staging area. So we do that using git add, then the file name. Now if I do git status again, you can see that changes to be committed. There is a new file readme.md. So before we commit changes to our repository, we need to set our name and the email. So what you need to do is git config global user.name. You have to give your name. I'm gonna just give Mansoor, and git config global user.email. Then you have to give your email ID. It doesn't really matter if you give a real email ID or not. This is what the Git will store in its commit history. Let's go ahead and commit our change. The command is git commit. So you simply do git commit and it will open your text editor. Let me just close this once. And so here you can see that aborting commit due to empty commit message. So because we just quit the text editor without making any changes, it said it aborted the commit. Okay, good. So which text editor Git uses to edit the commit message when you do git commit depends on your editor environment variable. Let me check what the variable is right now. If I do echo $editor, I can see that it is Vim. So you can change it by doing export editor equal to whatever the editor that you want to. If you want to use nano, you can do it like that. Okay, let's go ahead and commit our change. So here you can see that it says please enter the commit message for your changes. So right now what we are doing is we have made a new file and we have added that file to the Git, and we are going to make that change store in Git's version control. So here now we have to give a message that is identifiable to us as to what was the change. For example, if I just give created the readme file. So this is the message that I have given for the commit. So if I do save, if I save the file and quit it, it says master root commit created the file, created the readme file, one file change, 2 insertions. Okay, so we have created the file. We can check the file again. It's still the same, and we have committed that change into the repository. The next command is git log. You can use this command to see all the changes in the repository. So if I do git log, here you can see the first line says commit and then a hash. So this is called the commit hash. This long string is called the commit hash, and this uniquely identifies this specific change that we did. And here we can see the commit message, and the email and the name that we just configured will show up here. This is why we set the email and the name. There is a useful switch to the git log command, that is git log -p. if you do that, you can see the actual change itself. So here you can see that these plus signs implies that these are additions. You can see that this change added these lines. Let me make another change. So I opened the file again and I'm going to add another line saying this is line 1 or something like that. Okay, so now if I do git status again, it says modified because we just modified the file. We can actually see the changes that we just did using the command git diff or diff for difference. Here you can see that we just added this line. Again, if you want to commit this, we do add and then again commit. So this time git commit has this useful switch, that is -v. If you do git commit -v, it will show the changes inside here itself, where you can look at the changes and add your commit message. You can see add line 1. So let me save that. Let me add another line. Again git diff. Okay, this is line 2. Again git add and git commit. This time I'm not gonna open the editor by using git commit or git commit -v. Instead I'm gonna do git commit -m. So what this means is you can actually commit the change in a single line by providing the commit message as an argument here. So I'll just add a line 2. It's the same as before. It's just that you can do it much quicker. But I prefer to do git commit -v because I can be sure what are the change I'm committing to. Okay, so if I do git log, you can see that we have a few changes now. We added line 1, line 2, and things like that. So if you do git log -p, you can see all the changes that we did over the time. You can scroll, or you can actually use the arrow keys to see the older changes all the way back to our first change here. Okay. So far, so good. Let's create 2 more files. Okay, let's create a file called greet.py. And I'm gonna create another file called hello.py. And I'm gonna import this module from the file that we just created. Okay, so that works. So we just created 2 files. And Python itself created a directory called pycache. Okay, so if you do git status now, we can see that there are 3 untracked files in here. So this is where the usefulness of staging area comes into picture. So if you remember previously, in order to commit a change, you need to first stage it using git add and then commit it using git commit, right? At least some of you might have thought why do we need to do that? Why don't we just commit it directly? Well, here is the usefulness of staging. So in this case, we don't care about this directory. It was created by Python as part of running the script, right? We only care about these files. So what we can do is we can add only these files. For example, greet.py and hello.py. And if you do git status again, you can see that we have added these 2 files and this is still untracked. So I can easily commit the 2 files. And this one is not stored in our repository at all. That is, we are not tracking this. We don't really care about it. We don't want any change to this stored in our repository. So when you're working with a lot of these projects, there will be so many files like this or folders like this that you don't really care about storing in the repository, but it will get created or generated as part of running your programs or something like that. You can ignore them using something called gitignore. So all you have to do is you have to create a file called gitignore. So I'm just going to create that file, gitignore, and I'm going to copy this. So all you have to do is whatever you want to ignore, you just add it here in this gitignore file and save it. So if you do git status, you can see that this is gone now. And we have the gitignore itself, obviously because this is a new file. Now if you want to ignore gitignore also, you can just add to the same file and it will be, gone. Nothing to commit, working tree clean. But usually it's a good idea to leave the gitignore as part of the repository, because that way anyone who is working on these repositories or working with these programs, they won't have to do the same again. Okay, so I'm just going to leave the gitignore as part of the repository. Okay, so let me just add it and commit it. All right. So if I do git status on branch master, nothing to commit, working tree clean, because we have committed all the changes that we have made so far and there is nothing left to commit. So let's say I made changes to the both the files, greet.py and hello.py, and let's say I just added a comment. So I just added 2 comments. So if you do git status, you can see that it says 2 files are present. Now you can add them one by one using git add, greet.py and then hello.py, or you can do git add dot. Be careful with this. Dot means this current directory. It will add everything in this current directory. That means if you had changes that you really didn't want to add, that will also be there. But what if you just wanted to add only the py files? So you can do git add star.py. This will just add only the py files. So I'm just going to add it like this. And both of them are added, and commit. Okay. If you take a look at git log, we have all the changes that we did. So now what if you accidentally made a mistake and you want to revert that change? So you can do git log -p and see, okay, in this commit, we have added the comments, the module to both the files. What if you want to revert this change? You made a mistake and you want to revert this mistake. So you can just copy this commit ID and do git revert, then the commit ID. What it will do is it will open up the editor again, and this will be another commit. By default, it says revert at the commit, whatever the commit message was. And below that, it says this reverse commit the commit ID. So I'm just going to save it. So if you do git log again, you can see that has been added as another commit. And if we take a look at the files, you can see that the command has been removed because we just removed it using git revert. You can do git log in the overall repository. Also, you can do git log per file. For example, if you do git log the file name, you can see all the changes that were done to that file. The same goes for git log -p. You can see that all the changes that happened to that file is present here. So now let's say you wanted to go back to this commit. That is, you want to go back to the file how it was in this commit. To do that, again, copy that commit ID, do git checkout, the commit message and the file name. So if you do, open the file, you can see that this has been removed. So again, if you, copy this and you do git log -p, the commit ID, you can see that the commit ID said, hello, this is line 1. That is, whatever change was there at this commit will be present in the file. Okay, so far we have been working on a single branch, and that is the default branch, which is master. So if you do git branch, you can see that it's the master branch, and that's fine if you are the only one working on that project, or you are doing one thing at a time. But what happens if you have so many people working on the same project, or what happens when there are parallel developments happening? Let's say, for example, one person is fixing a bug and another person is working on a feature, etc. So we need a way to have all of this work done at the same time without affecting each other. So that's where branches help us. You can have any number of branches working parallel to the master branch, and whatever you do in that specific branch will have no effect on the master branch or any other branch until and unless you merge that branches together. Okay, so we have our files and everything. Let's create a new branch. You create a new branch using the command git branch, then the branch name. And if you do git branch again, you can see that the other branch is present here. You can switch to that branch using git checkout branch name. And now if you do git branch again, you can see that the star has moved to the branch name. All right, let me just switch back to the master branch. And there is a better way to do that. That is by using git checkout -b and then the branch name. Let me just call it add feature or something like that. Okay, so I just created a branch add feature and switch to that. So let's make some changes. Let's say I just added hello there, and just added this comment so that we can easily identify the difference. Okay, so if I do git diff, you can see that the change is there. So I'll just do a git status, and I'll add both the changes and then commit. All right, so if you do the check the greet.py, we can see that the change is there, obviously. So now what happens if I switch to the master branch? And if I open the file, the change is not there, because whatever change that happens on a branch stays in that branch until you merge that. So let's say you have made enough changes to your feature branch, and now you want to merge this to the master branch. So how do you do that? That's where the git merge comes into picture. Remember, we are now on the master branch, and you do git merge add feature, and you can see that it just added that change. So again, I'm on the master branch, and if I open the greet.py, you can see that the change is there. So now that you have merged this change to your master branch, you don't really need this old branch, right? So you can delete the branch using git branch -d branch name. Let me just delete the other branch too. So far, we talked about creating a local repository, adding and committing changes, checking the diff, checking the log, and reverting the change, and branching. So that's like the basics of Git, and that's actually enough for you to get started on any project to use Git. Now let's talk about GitHub. So what is GitHub? Well, GitHub is an online service that does Git repository hosting. So if you don't have an account in GitHub, now would be the right time to create an account. It's free, and you should definitely have a GitHub account. So this is what we're going to do now. We're going to create a repository in GitHub, and by doing that, we're going to talk about remote repositories, and then we're going to clone the repository, pushing changes to the repository, and then creating a pull request. So this is what we're going to do now. All right. So back in github.com, I'm just going to go ahead and create a new repository. So I'm just going to name it DevOps demo or something like that. So click create. So here you can see that GitHub by default gives you some information on to get started with your newly created repository. We're just going to ignore that for now. Before we do any of that, the first thing that we need to do is, if you haven't added any SSH key in your GitHub repository, in your GitHub account, we should do that. So I'm just gonna go ahead and click on settings. Where is settings? Okay, settings. And under SSH and GPG keys, click on new key, and you go ahead and copy your SSH public key. Remember, this is the public key. It should look something like this. You go ahead and paste it here. So now using this SSH key, you can clone your own repository, or pull or push changes to your repositories via SSH. Okay, so there are two ways you can get code from your GitHub repository. One is via HTTPS. If you click here, you can see that it changes to HTTPS, then github.com/whatever. And if you click here, you can see that it changes to git@github.com, and then your username and the repository name. So there are two ways you can communicate to GitHub. One is via HTTP, and the other one is via SSH. So if you are going to do HTTPS, if you try to push any change to this repository, for example, it's gonna ask you to log in with your username and password. Similarly, if you have your SSH keys set up, you can simply use the SSH option and that should work flawlessly. So since now I have created my SSH key in GitHub settings, I can simply use this to clone the repository. Also make sure you remember this distinction. This is a public repository. That means anyone can clone this via HTTP. It doesn't matter, anyone can clone it. But you won't be able to make any changes to the repository. If you try to push a change to the repository, it will ask you to enter your login in a username and password, and you obviously won't have permission to do that because I haven't given permission to anyone yet. So I'm just gonna do the clone through SSH. I'm just gonna clone it here. So the command that you do is git clone, then git at whatever is GitHub giving you. So I just cloned the repository, DevOps demo. So if you do git remote -v, you can see that the origin has been identified as git at github.com and then, my username and the repository name. Alright, so let's just go ahead and create a new file. Okay, so git status, a new file. We'll just do the git add and we'll commit it. And I will just push it. So now this is a new command, git push. So git push means to push the change to the remote repository. So in our case, the remote repository is this one, the one we just created. So you can just do git push origin. And what is this origin? Origin is the name that we have just given to our remote. Here, this is the name. You can just name it whatever you want, by default, and this is a kind of a convention. It's named origin. So git push origin master. Why master? Because we are pushing to the master branch of the origin repository. It worked fine because I have permission to push to my repository, because I have already added my key. So if I go to the repository, you can see the change here, and it says it created a new branch because by default the repository was empty and there was nothing in there. So now I just pushed it and it created a new branch. Okay, good. But pushing directly to the master is not always a good idea. It's fine if you are just working on your own projects and you're the only one working and you know for sure that nobody is there to review the changes and things like that, then it's fine. But when you're working with multiple people, the usual way of doing is by using branches. So again, I'll just do git branch. We are obviously on the master branch. So now let's say I want to work on a new feature. So I'm going to create a new branch, git checkout -b and the branch name. I will just say create script or something like that. And now we are in that branch. Okay, so I'm just going to create a new file called hello.py and I'm just going to say, alright, so we'll do git status again and we'll do git add git commit -v to commit the change. Remember, we are in the branch create script. And now what we're going to do is we're going to push it to that branch, git push origin create script. What is the difference here? Previously we pushed it directly to master. We did git push origin master. Here we are doing git push origin create script. So what it means is we are asking Git to create a new branch called create script in the remote repository and then push the change to there. Alright, so it did the change. So now if I come here, you can see that it says create script has recent pushes less than a minute ago. Compare and pull request. We'll come back to that in a moment. But if you look here, you can see that it says master here. So if you click here, you can see the other branch we just created, that is create script. Remember, in the master branch, there is no new file. Python file is not created in the master branch. But if you switch to this create script branch, you can see that the hello.py is present there. Okay, so again, so it says compare and pull request. So now this is one of the feature of Git called pull request. So if I click on it, it says open a pull request. So here you can see that the base branch is master, and the branch we are comparing it to is create script, which is the new branch we just create. So if I scroll down, you can see that the change that we just trying to merge, it says one changed file, and you can see that we just created a new file called hello.py. So you can just give a comment saying and you click on create pull request, and we just created our first pull request. You can see the changes in here, files changed. A pull request means exactly what it sounds like. Well, actually, you know what? It makes more sense to call it merge request, and that's what Gitlab does. Here, Gitlab is another Git repository host similar to GitHub. They all uses the Git tool for everything. It's just that sometimes they have different terminologies. Pull request in Gitlab is called a merge request, which actually makes more sense because we are creating a new request to merge our change into the master branch, which you can see here. Mansoor wants to merge one commit into master from create script. All right. So if you do merge pull request, you can see that it has been changed from open to merged. So if I go to the repository again, you can see that the hello.py file is created. All right. So we created a new repository in GitHub, and we pulled the content from there, and we pushed it back to the same remote repository, right? What if you want to just create a new repository and add it to an existing code base? You know what? Let's go ahead and create a new repository, and I'm going to call it DevOps demo existing. You can see that here it says or push an existing repository from the command line. All right, that's exactly what we're going to do now. Remember our my app repository that we were working with previously, and we don't have any remote added to it. We were only working locally, right? There's nothing there. So what we have to do is we have to add a remote here, and GitHub is giving you the instructions to do that. Git remote add origin. This is the name. Remember, you can give it any name, but origin is preferred. And then the URL. So I'm just going to copy and paste it. And if I do git remote -v, you can see that it has been added. We are already in the master branch. So all we have to do is git push origin master. And if I go to the repository, you can see that all our files from our previous exercises, we were talking about the local Git repository, is present here. Okay, so now how do you get the changes other people have made into the repository? Chances are you are not the only one working on the repository, right? Other people might have pushed their changes back into the repository. They might have created their own pull requests and merged the changes back to our master branch. So now we need to get all of these changes back to our local repository before we can do more work on that, right? So what I'm going to do is I'm going to create another directory. Let's just say that's another employee. Now I just created a directory called another guy, and I'm going to clone it. Hit clone. Let's say I create another branch called feature1, and I am going to create change add feature1. Commit and push it to the feature1 branch. Remember, we are doing this from another repository, another local repository. So here it says create a pull request for feature1. You can just copy this directly and open it, and it will create the pull request. So created the pull request, and I'm just gonna merge it. All right, so now it's present in master. Let's go back to our original repository. Now if I do git branch, it shows the local branches. If we do git branch -a, it will show the local and remote branch. Here it shows the remote /origin/master. But it's not showing the branch that we just created from the other local repository, right? So to update that, you do git fetch. And here you can see that it said new branch. So if you do git branch -a again, you can see that the branch is created here. But if we look at the hello.py, the change is not really present here, right? So you get the changes from the remote onto your local repository by doing git pull origin master, because we want to pull the latest stuff from the master branch. And here you can see that the change is present now. So you make sure that always pull the changes before you make a new pull request or something like that. Now let's say you're working on another branch. Let's say bug fix. Okay, so you haven't touched the master branch yet, and then you've been completely working on this bug fix branch. Now let's go back to the other guy, and we'll just switch to the master branch. We'll just do a git pull origin master. All good. And let's say we are going to add another change. Saved it. We're going to push it directly to master for now. All right. So back to our original local repository. We are still working on our bug fix branch. We don't know what happened in the master branch and anything like that. So, let's say you added a bug fix and you committed that. And you pushed your stuff into the bug fix branch. Now this is fine because you made a change to a different file, right? But what if you are actually making the change in this file itself? The file that is actually modified by the other person from the other local repository. Let's just see what happens. And I'm gonna push that bug fix. So let's go back to the GitHub UI and create compare and pull request. But it says can't automatically merge. So if you create a pull request, it says this branch has conflicts that must be resolved. So what happened here? So what happened is, while we were working on our hello.py here, the other person have added changes to the same file and that was merged to the master branch, but we did not get the latest changes back into our branch. That's what happens when you don't pull master into your branch before you're creating a pull request. So always remember to pull master onto your branch before creating a pull request to merge the changes back into the master branch. So what we're going to do is, we are in this bug fix branch and we're going to do git pull origin master. And you can see that it says conflict, merge conflict in hello.py. So if you open the file, you can see that there is this weird lines added by Git. So what happened is, when we merged these two files together, Git was unable to make the decision on what to do with these changes because the file in this local repository did not have this one change that came from the remote master branch, which was pushed into the master branch from the other local repository. So Git is saying, I don't know what to do. You have to figure this out yourself and see what's the latest change should be. So what we have to do is, we have to look at the change and see what actually should be present. Now in this case, we know that we need both the changes. So we can just simply delete the whatever things that is added by Git and just save it. And if you just do git add the same file and commit it, you can see that it automatically says merge branch master of whatever. That is because we just fixed a conflict, and now Git is able to merge your master branch into your local branch. So let's just do that. And if we do git push origin bug fix and reload the page here, and you can see that it's all fine. And now you can see that this change is already present there and we are just adding a bug fix here. So that's how you fix a conflict. So you can now easily merge the pull request without an issue. So again, remember to always pull your changes from master before creating a pull request or before you start working on a new project. Otherwise, you're gonna have a hard time fixing a lot of conflicts. Alright, so that's pretty much it for this video. Thanks a lot for watching. If you found this useful, please leave a like. It takes a lot of effort and time to make these videos, and your appreciation is what's keeping me motivated to do all of these videos. See you in the next one.